Okay, now recording. Okay, so we're here. Believe it or not, we're already in week 8 of the semester, week 8 out of 17. So we're close to being halfway. Not quite. I guess technically that would be halfway through next week, but we're getting there. Well, we have 5 chapters. We're in the 3rd chapter, which is the middle, and we're getting pretty close to the middle of the middle chapter. I guess that's one way to look at it. Okay, so we're doing 3.4. Again, for now, we're aiming for roughly 3 sections a week. So last week we did 3.1 and 3.3, and then this week 3.4 to 3.6, week after 3.7 to 3.9, and then week after that will be our test, will be 310, 311, and then hopefully a day for review, and then test 3, and then we get a week off for the spring break, right? So that's where we're at. Okay, so we're doing the chain rule. I just introduced that concept last time, and we'll try to do more now, okay? All right, so back to the chain rule. Okay, so 3.4 on the chain rule, and what you want to put on your formula sheet in particular is this on page 198. Okay, if capital F of X is defined by a composition, F of G of X, to differentiate the whole thing, you take F prime of G of X times G prime of X. Take the derivative of the outside function with respect to the inside function, and then you multiply by the derivative of the inside function. Okay, so that's the basic form. And one thing I should hasten to add is that's the easiest case scenario. I mean, the inside might be a composition itself. So you may have to do this several times over, hence the term chain rule. You may be chaining one function on top of another. Okay, I think one of the homework examples, you actually have to go 5 deep. You have a function inside a function, inside a function, inside a function, inside a function, in which case you have to do the chain rule 5 times, I believe, at the maximum. Okay, but the easiest ones, quote unquote, are where it's just an inside and an outside function, F of G. Okay, but again, they might later give you 3 functions, F of G of H, and I think the hardest one they give you is 5 functions. Okay, a function inside another, inside another, inside another, inside another. This form, you can put it down, but you don't really need to worry about it too much. There's not going to be that many problems that are like that, okay? So I showed you just one example last time. I'll show you that again, and then we'll do some more after that, okay? All right, and yeah, anybody who just joined or joined late, go ahead and put it in the chat. But now for the chain rule, right? So problem 7 that I did last time, but I'll just show you quickly again. So capital F of X is 5x to the 6th plus 2x cubed to the 4th. Okay, so it's not as easy as just x to the 4th. We know the derivative of x to the 4th is 4x cubed. It's a function to the 4th power. So there's a function inside a function. The outside function is raising something to the 4th power. Inside function is this. Okay, so you take the derivative of the outside function with respect to the inside, meaning it starts off as you might expect, 4 times blah, 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 5x to the 6 plus 2x cubed. But the chain rule now says it's times the derivative of the inside function. Okay, so we did the derivative of the outside with respect to the inside, and then times the derivative of the inside function. So now I have to differentiate 5x to the 6th plus 2x cubed. So that's equal to 30x to the 5th plus 6x squared. Okay, so that's how the chain rule now works. Okay. All right, so we're doing a whole bunch of these now more. Okay, 13. Y equals x squared e to the negative 3x. Okay, so that's a product rule. There's also a chain rule here because we're not just differentiating e to the x, it's e to the negative 3x. Okay, so there is an inside function, negative 3x. The outside function being the exponential function. Okay, so here we go. It's the first function, x squared, times the derivative of the second. So what's the derivative of e to the negative 3x? it's e to the negative 3x. That's the normal part. You just copy the original. But now it's times the derivative of the exponent. That's the inside function. So the derivative of negative 3x is negative 3. All right, so that was all first times derivative of the second, plus the other way around, second function, copy the second function, e to the negative 3x, times the derivative of the first, the derivative of x squared is 2x. Okay, so that gives me negative 3x squared, e to the negative 3x, plus 2x, e to the negative 3x, and that's my final answer. Okay, so we'll do a little bit more with taking the derivative of exponential functions also. And that reminds me, I'm not sure if I gave you the picture, so I'll show it to you again. If I did, then fine, you have it again. So for those of you that don't have the book, so we got to go up to 65. It's on page 204. So if you need it, you can watch the video and get the problems. That goes up to about 10, it's about 20, 29-ish. Okay, 31, you can see up to about 43, 27. Okay, and how high do we have to go again? Was it 65, I think? Some more there, there. And yeah, you need the graph for this, 65. I think 65 was the last one, if I'm not mistaken. So there we go. Yeah, 65. All right, so here's a problem that I just made up. It's not necessarily in the text, although it shows up in some form. What's the derivative with respect to x of e to the x squared? Okay, so you have to watch out. It's not just e to the x squared. The derivative of e to the x is e to the x. But for e to the x squared, there's a function outside the exponential function, and there's an inside function. Okay, so you take the derivative of the outside function with respect to the inside, e to the x squared, that's normal. But now it's times the derivative of the inside function. X squared is considered the inside function. So derivative of x squared is 2x. So final answer is 2x e to the x squared. All right, so now we can tackle exponential functions which are not base e, and you'll see in just a second that it's not so nice. Okay, so the derivative of e to the x is itself. Derivative of e to the x is e to the x. What if I have some other base now? Okay, what's the derivative with respect to x of 2 to the x, 10 to the x, a million to the x, pi to the x, and so on? Okay, so how do I take the derivative of 2 to the x? Okay, and now that we know how to differentiate an exponential function with a base of e, there's a little trick we can do. So if I want the derivative of 2 to the x, I can write 2 in this fashion, e to the ln 2. E to the ln 2 is the same as 2, right? If I only looked at this, then you would remember from your algebra, oh yeah, e and ln cancel out. So it is 2 to the x power, right? So I can write 2 as e to the ln 2. And then I have a property of exponents that says if I have a power and another power, I get to multiply these powers, e to the x ln 2. Okay. So what's floating up here is x ln 2. The coefficient is ln 2. Okay. It's like saying 0.693x. Okay. And by the way, in case you're wondering, should I write the ln 2 before the x? It's clumsy that way and it's ambiguous. So I'll write something over here, but it's just to show you that there's problems writing it this way, right? If you write it like this, you're saying, do you mean natural log of 2 times x or ln of 2x? In fact, the normal way to interpret this is ln of 2x, right? So that being the case, I'll just lightly cross it off to show you. We prefer not to write it this way. We prefer to write it as x ln 2, the coefficient being ln 2, which is about 0.693. Okay. See, if I write it like this, there's no way anybody's going to think that means 2 times x, right? So this is x ln 2. This is kind of ambiguous, right? Do you mean natural log of 2 times x or ln of 2x? So to avoid that ambiguity, you usually write it like this. Okay, so now that looks like what I did over here. Okay, so what's the derivative with respect to x of e to the x ln 2? It's e to the x ln 2. Pretend that's like 0.6932. And then by the chain rule times the derivative of x ln 2, that's natural log of 2. Well, I can rewrite this back as this e to the x ln 2 stuff was originally 2 to the x. So I have 2 to the x ln 2. Right? So the derivative of 2 to the x is 2 to the x natural log of 2. And you can kind of tell the algebra is exactly the same for any base. Okay, if I had base 3 to the x, pi to the x, 10 to the x, the algebra would be identical. So we now have a new rule that you're going to put on your formula sheet to differentiate a to the x. So a to the x prime is a to the x natural log of a. And you can see it's more clumsy than just having base e. So that's why I say in calculus, we like base e. The derivative e to the x is just e to the x. If you want the derivative 2 to the x, a little bit harder, you have to go 2 to the x ln 2. What's the derivative of 7 to the x? 7 to the x ln 7, and so on. Okay, and I'll go ahead and show that to you in the text now. On page 202, number 5 there. Well, they use the letter b. I guess that makes sense for base. Okay, so box 5, the derivative with respect to x of b to the x ln b. Okay, so you can see they have 2 to the x also, right? Derivative of 2 to the x ln 2. Definitely not as nice. So what's the derivative of 10 to the x? 10 to the x ln 10. What's the derivative of a million to the x? A million to the x times natural log of a million. Okay, so you can't get away with that ln. Okay, so the one that we like the most in calculus is base e, because if it's e to the x, we don't have to worry about it. It's just e to the x. And you say, technically, if this is supposed to work all the time, I should also say for e to the x ln e. That's true, but ln e happens to be 1, so it even works in that exception there. Okay, so put this on your next formula sheet, the derivative of b to the x ln of b. Okay, or I have the same thing, a to the x ln a. Okay, all right. Okay, so let's move on. I'll do some more complicated ones. 15. Okay, e to the at sine of bt. Oh boy, so there's a lot of stuff going on here. Okay, so there's a chain rule for this exponential, there's a chain rule for the sine, and there's a product. Okay, so you have to deal with the whole thing. All right, so the first function is e to the at, second function is sine of bt. All right, so product rule, first function, e to the at, times the derivative of the second. So what's the derivative of sine bt? Derivative of sine is cosine, so cosine bt. And then by the new chain rule, it's times the derivative of bt. Keep in mind, b is a constant, t is the variable, so multiplied by an extra b. Plus second function, sine of bt, copy it, times the derivative of the first. So I differentiate e to the at, the derivative would be e to the at times a, which is the derivative of t. Okay, and technically, one last step, I decided not to do it, but you can do that easily. Okay, just put the b in front, coefficients belong in front, and put that a in front. And that's basically about it for that one. Okay. All right, come to other ones here. 25. G of u is u cubed minus 1 over u cubed plus 1 to the 8th power. Okay, this one's going to be a little bit messy. Okay, but the outside function is raising something to the 8th power, right? So we know how to do that. It's going to be 8 blah, blah, blah to the 7th power. That's easy. And then by the chain rule, it's times the derivative of the inside. But if I differentiate the inside, I have to do a quotient rule, right? So it's going to be quite messy. So here we go. 8 u cubed minus 1 over u cubed plus 1 to the 7th power. Okay, so that's done. And now it's times the derivative of the inside. So now I have to differentiate a quotient. So here we go. Bottom times the derivative of the top. Derivative of the top is 3u squared. Minus the top, u cubed minus 1, times the derivative of the bottom, 3u squared. All over u cubed plus 1 squared. Okay, now I just clean it up. Ignore that I messed up there. Okay, so there's an 8, u cubed minus 1 to the 7th. I have u cubed plus 1 to the 7th on the bottom, and a u cubed plus 1 squared. So that's a grand total of u cubed plus 1 to the 9th power. Okay, 7 here, 2 here, grand total of 9. Okay, right here I factored out the common factor of 3u squared. Okay, normally it's not worth it to multiply at the bottom. Well, neither you nor I really want to multiply this out to the 9th power. Forget that. Okay, but we sure work out the top, especially since there's going to be some cancellation. There's a common factor of 3u squared, so I took it out. And then I have left u cubed plus 1 minus u cubed minus a minus 1. So that's plus 1. Okay, cancel, cancel. 1 plus 1 is 2, right? So all of this stuff here is 2. So what do I have left? 8 times 3 times 2. 8 times 3 is 24, 24 times 2, so 48. I have a u squared. I have this thing to the 7th power, and in the bottom I have u cubed plus 1 to the 9th power. So it looks like that's my final answer finally. Okay. All right, 27 is our first instance where the base is not e, 10 to the 2 radical t. So a little bit more clumsy. R of t is 10 to the radical t. So radical t treated as t to the 1/2. Right, so the outside function is the exponential 10 to something. The inside function is the exponent. Okay, so here we go. So how do I take the derivative of 10 to the 2 radical t? So I'm using advantage of this new rule. A to the x prime is a to the x ln a. So the derivative of this is same thing, 10 to the 2 radical t times natural log of 10. Okay, again, we don't like that extra ln. That's why we like base e in calculus. 10 to the 2 radical t, ln 10. And then by the chain rule, it's times the derivative of the exponent. So I look at this now, 2t to the 1/2. So the derivative is 1/2 times 2, which is 1, t to the negative 1/2. Okay, then clean it up. I just put that in the denominator, right? T to negative 1/2 means radical t on the bottom. So final answer, 10 to the 2 radical t, natural log of 10, divided by square root of t. Okay, and this is just a side note. The last time I taught, I made up this one just to show you a basic idea of how the chain rule works, right? So if y equals 2x squared plus 5x minus 7 cubed, notice the structure. The derivative is 3, 2x squared plus 5x minus 7 squared, times the derivative of the inside. So I differentiate the inside, which is 4x plus 5. Okay, so that's the way this new chain rule works. Okay. All right. Okay, yes, I see some questions in the chat. I want to cover what I need to cover first, and let's see from there. I do want to show you some of these real bad ones, especially. Okay, 31. Okay, so this gets a little bit more scary. E to the t sine 2t. Okay, now the easy part is the e. Outside function is the e. inside function is a product rule and a chain rule, because it's not just a sine of t, sine of 2t. All right. So we know how to differentiate e to something. It's the same thing times the derivative of that exponent. And that looks like a product rule and a chain rule. Okay, so here we go. So if f of t is e to the t sine of 2t, f prime is same thing, e to the t sine of 2t. Okay, so that part's now finished. So now pretend the problem just asks for the derivative of t sine of 2t. It's a product. So parentheses, you got to put parentheses around the whole thing. So first t times the derivative of the second. So what's the derivative of sine of 2t? Cosine 2t times the derivative of 2t, which is 2. And yes, normally in the final answer, you put the 2 in front over here. Okay, plus second function, sine of 2t, times the derivative of the first, which is the derivative of t, 1. Okay, so the only thing I would do for the final answer is put the 2 in front with the t, and there's my final answer. E to the t sine of 2t times the derivative of the exponent, which is now 2t cosine 2t plus sine of 2t. Okay. All right, I wanted to show you 39 and 45 because they're much more messy. 39 is a composition of 3 functions: tangent, secant, cosine. 45 is just about as bad as they get. 45, there are 5 functions involved: cosine, square root, sine, tangent, and then pi x. So we have to do the chain rule 5 times for 45. So I was going to show you those. Okay. All right, so 39, f of t is tangent of secant of cosine t. And sometimes I recommend, again, if seeing this whole thing makes you dizzy, don't even look at the whole thing. Just think to yourself, I'm taking tangent of something, right? This is messy. I don't like looking at it. Then don't look at it. Just go like this, tangent. Right. What's the derivative of tangent of something? You can put it on your cheat sheet. It's secant squared, right? So I just copied down secant squared of this inside thing, secant cosine t. Right. So now I'm finished with the tan. Now the chain rule says it's times the derivative of secant cosine t, which is a composition. Okay. So times what's the derivative of secant? Secant tangent. So I go secant of this thing, cosine t, tangent cosine t, right? Again, the derivative of secant of something is secant of that thing, tangent of that thing. So secant cosine t, tangent cosine t. I'm now finished with the secant. And now the chain rule says again, times the derivative of the inside function. So what's the derivative of cosine t? Negative sine t. So there it is. And for something that's bad, you can just leave it. Okay, so one more time. You take the derivative of the outside function. The outermost function is tangent. Derivative of tangent of something is secant squared of that thing. So secant squared of that thing, secant cosine t. Right, tangent's done. Then times by the chain rule the derivative of the inside, which itself is a composition, secant cosine. So think of just secant. How do I differentiate secant? Secant tangent. So secant of this argument, as it's called, cosine t. Secant cosine t, tangent cosine t. Okay, secant is done. Now times the derivative of the cosine, which is negative sine t, and then I'm finally done. Okay, 45 is pretty long. Okay, so there's 5 functions. There's f of g, of h, of j, of k functions, right? So the functions are, the outermost is the cosine. Next one is square root. Next one is sine. Next one is tangent. Next one is pi x multiplying by pi. Okay. And by the way, some of these functions are allowed to be repeated. In fact, if you look at 53, good example, sine of sine, that's okay. Sine of x, you can repeat any function. All right, so what's the derivative of this mess? So the outermost function is cosine. You say, I don't like looking at the whole thing. Don't. Just look at the outside. It's cosine. Right? How do I differentiate cosine? Negative sine. So I put negative sine of all of this stuff, square root of all that stuff. Okay, so negative sine, square root of sine tan pi x. It's a lot, but at least it's just copying. Okay, so I'm now done with cosine. So what is the next function? The square root function. Remember, square root means blah, blah, blah to the 1/2. So it's sine tan pi x to the 1/2. Whose derivative is 1/2 sine tan pi x to the negative 1/2. Okay, square root's finished. So now I'm at differentiating sine of something. What's the derivative of sine of something? Cosine of that. So cosine tangent of pi x. Okay. So cosine tangent pi x, so that's finished. Now by the chain root times the derivative of the next inside function. The next inside function is tangent of pi x. How do I differentiate tangent of something? Secant squared of pi x. So tangent's done. I'm now done with 1, 2, 3, 4 functions. I did the cosine, I did the square root, the sine, and the tangent. One more function, then I'm done. So it's times the derivative of the inside function, which is now pi x. What's the derivative of pi x? Pi. Finally, I'm done. So there we go. Okay. It's a mess, but you think of it strategy-wise. Okay, start with the outermost function, cosine. Okay, take that derivative, copy all the inside stuff. Okay, then I'm finished. Then the next function, square root. How do I take the square root function, derivative of square root? Remember, it's like blah, blah, blah to the 1/2. So 1/2, copy all the inside stuff to the negative 1/2. Okay, square root's done. Next one, it's like next, right? Next in line, next, right? Next one is sine. How do we take the derivative of sine? Cosine of everything that's inside, tan pi x. All right, next in line, tangent, secant squared. Okay, next, pi x, pi. So there we go. All right, I want to show you 53. It's a function of a function, but it happens to be the same function. Okay, so 53. Find equation on the tangent line. Okay, we know what that's above. It's going to happen over and over and over in the class, right? Sine of sine x, and the point is pi comma 0. Okay. So what's the derivative of sine x? So it makes me too dizzy to look at it and just look at the outermost function. How to differentiate sine of something? Cosine of something. So it's cosine of, you keep all of this the same, the argument the same as it's called, cosine of sine x times the derivative of the inside. So now pretend all you see is sine x. What's the derivative of sine x? Cosine x. So that's the derivative of sine x. Cosine sine x. Don't change that, just keep that alone. Keep it as it is. And now it's times the derivative of the inside, which is cosine x. All right, y prime of pi, plug in pi. So cosine sine pi times cosine pi. So sine of pi is 0. Cosine of 0 is 1. So I have 1 times negative 1. So the slope is negative 1. Point slope form. Y minus y1, y minus 0 equals negative 1 times x minus pi. And again, you can stop right after that. So that is that. Okay, raise it up again for better viewing. If it was all out of focus a little bit at first. Okay, that's all that. Okay, and maybe I should do the same thing on everything I did here. So the others, this was the beginning of class. Maybe I didn't raise it up for focusing. If you want to see it better on the video later, maybe. That and that. And that. Okay. Okay. All right, I'm going to jump around for some of these other ones. I want to make sure I show you some of each type. Okay, so 3.4. Let me show you the idea behind 17, which is the product rule. Okay, but each of these products has a chain rule because it's blah, blah, blah to the fourth, blah, blah, blah to the fifth. Okay, so ultimately it's a product. First function, second function. Okay, so copy the first function, 2x minus 3 to the fourth power, times the derivative of the second. So how do I differentiate this? 5 x squared plus x plus 1 to the fourth power times the derivative of the inside, which is 2x plus 1. Okay, all of that was first times the derivative of second, plus second function. So copy the second function, x squared plus x plus 1 to the fifth power, times the derivative of first. So what's the derivative of this thing? 4, 2x minus 3 cubed, times the derivative of the inside, which is 2. Okay, and yeah, I'm just going to say etc. here. You can keep going. So what can you keep going? Well, easy stuff like 4 times 2 is 8, and normally you put the 5 in front, so that's easy. But I'll let you try to figure that out on your own. Okay, then I'm just going to show you 41 also because that was a little bit tricky. F of t is sine squared e to the sine squared of t. So there's a couple of sine squareds in here. Okay. Now remember, sine squared means sine of something squared. Okay, so quick timeout. If I say sine squared x, it means this, right, from trigonometry. So the outermost function is the squaring function. It's really this thing squared when we write sine squared of blah, blah, right? So the outside function is the squaring function. It's blah, blah, blah squared. So how do I differentiate? How do I differentiate the squaring function? 2 times sine of blah, blah, blah to the first power. 2 minus 1 is 1, which means I don't have to write it. Okay, so the squaring's finished. Times the derivative of the next inside function, which is sine of something. Okay, maybe don't even look at that. How do I differentiate sine of something? Cosine of that same thing, right? So cosine of e to the sine squared t. Right, so I'm done with the sine. Another chain rule, times the derivative of e to the sine squared t. How do I differentiate e to something? You put the same thing, e to the sine squared t. Okay, the e is done. Times the derivative of sine squared t, which again, treated as sine of t squared. So the outermost function here is the squaring function. So 2 comes down, 2 times sine of t to the first power, which means you don't have to write it, times the derivative of the inside function. And then I'm finally done. So what's the derivative of sine of t? Cosine t. So there we are. So here's another 5 function one. The 5 functions are the squaring function, the sine function, the exponential function, again the squaring function, and then the sine function. So 5 things. And yeah, I'm just going to leave it like that, but you can do easy stuff like 2 times 2 is 4. And normally this would be in the front, but that's pretty much about it. Okay. Okay, 47. 47 was asked for. Cosine of sine of 3 theta. Okay, find y prime and y double prime. I'm guessing y prime is not so bad, but y double prime might be bad. Okay. So I don't know. Let's see. Okay, so the outside function is cosine. So how do I differentiate cosine? Negative sine. So y prime is negative sine of the sine of 3 theta. Then by the chain rule times the derivative of the inside. What's the derivative of sine of 3 theta? Cosine 3 theta times the derivative of 3 theta, which is 3. So clean it up. Negative 3 sine of the sine of 3 theta times cosine 3 theta. So now I have to take the derivative of this mess to find y double prime. Right, the problem asks for y double prime. Where'd it go? Yeah, right here. 47. It's a product. So first function, second function. So here we go. Copy the first function, negative 3 sine of the sine of 3 theta, times the derivative of the second. So what's the derivative? Cosine 3 theta, negative sine 3 theta, and then times an extra 3 by the chain rule. Plus second function, cosine of 3 theta, times the derivative of the first. So I have to differentiate this mess. So the derivative of negative 3 sine of something is negative 3 cosine of the thing inside, sine of 3 theta, times the derivative of the inside. So every time you finish one derivative, you have to take the derivative of the inside function. So now what's the derivative of sine of 3 theta? Cosine 3 theta times the derivative of the inside function there. And what's the derivative of 3 theta? 3. Okay, so that's it. And again, I'll stop there, but if you really want to simplify, you can go 3 times 3 is 9, or negative 9, I guess. And I think there's a negative 9 over here also. So that's the way that goes. Okay. Uh, 61 is a little bit unusual. Let me show you 61. Capital F of x is a composition, f of g of x. And they tell you f of negative 2 is 8, f prime of negative 2, blah, blah, blah. They give you all that data. Find f prime of 5. So how do you do that? So I copied down all the data. If you missed the problem, it's all here. Or those of you that have the book, it's already there. Right. So by the chain rule, f prime of x, capital F prime of x, is little f prime of g of x times g prime of x. Okay, the question asks for capital F prime of 5. So I put a 5 right there, put a 5 right there. So it's f prime of g of 5 times g prime of 5. Okay, so they tell me in my chart that g of 5 is negative 2. So I change that to negative 2. So they want f prime of negative 2, g prime of 5. So f prime of negative 2 is 4. G prime of 5 is 6. 4 times 6 is 24. So that's how you do 61. Okay. And let's see, I had a request from somebody to do problem number 9. Okay, so let me go back and try number 9. Square root of 5x plus 1. Okay, so remember, square root means raising something to the 1/2 power. We've already seen that. So outside function is a square root function, which means raise something to the 1/2. The inside function is 5x plus 1. Right, so 1/2 5x plus 1 to the negative 1/2. Right, 1/2 minus 1 is negative 1/2. And then by the chain rule times the derivative of the inside. So what's the derivative of 5x plus 1? 5. And now just a little bit of touch up. 5 on top, 2 on the bottom. square root on the bottom. So 5 over 2 radical 5x plus 1, like so. And that's about it. Okay. I'll show that to you a little bit longer. You can always catch this on the video, of course. And in case you didn't catch everything here, raising it up for focusing, if you want to check the video later, in case what I showed you wasn't focused enough. And there's all that. Whoops. Okay. All right, folks. I was going to stop there and let you try one problem on your own. I know it's a little bit hard to type this in the chat, but try your best. Okay. Hopefully it's not too bad. Okay, I want you to try right now question number 8 on page 204. Type it in the chat, and when you're done, you can leave. Okay, so question number 8. F of x is 1 plus x squared to the 99th power. Okay, so for exponents, use the up caret. That's usually above the 6 on your keyboard, right? Above the 6 is normally the up caret. So everybody try number 8 right now, please. F of x is 1 plus x squared to the 99th power. When you finish, put it in the chat and you can leave, and I'll see you tomorrow. Okay, I'll hold it just for another 10 seconds or so. Hopefully you get it, and the book is heavy. So just number 8, f of x is 1 plus x squared to the 99th power. Try the chain root with that problem. 1 plus x squared to the 99th. Okay, all right, I'm going to assume that everybody has it now. Just question 8. And when you're done, you can type it in the chat and you can leave. Thank you.